Hello and welcome to yet another video of Cornerstones of Math. Today we are going to evaluate the sums of two series. The first series is 0 factorial over 2 factorial minus 1 factorial plus 1 factorial over 3 factorial minus 2 factorial plus 2 factorial over 4 factorial minus 3 factorial and so on. And the second series is 0 factorial over 1 factorial plus 2 factorial plus 1 factorial over 2 factorial plus 3 factorial plus 2 factorial over 3 factorial plus 4 factorial and so on. Let us take a look at this series first. Here, using the sigma notation, we can write this series as the sum of the general term n factorial over n plus 2 factorial minus n plus 1 factorial from n equals 0 to infinity. Now in the denominator, this n plus 2 factorial is n plus 2 times n plus 1 factorial. So we have n plus 2 times n plus 1 factorial here minus n plus 1 factorial. So we have n plus 1 factorial as the common factor. So taking out n plus 1 factorial, we have n plus 2 from here, then minus 1. So we have n factorial over n plus 1 times n plus 1 factorial. Again, this n plus 1 factorial is n plus 1 times n factorial. So we write n plus 1 times n factorial here. So n factorial cancel out, and we have sigma 1 over n plus 1 squared, which is 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, the sum of reciprocals of squares. This is the very famous sum, also known as the Basel problem. I am not going to prove here, but it is known that this series converges to the value pi squared over 6. So this is the sum of the first series. Similarly, for the second series, let us also express it as the sigma notation. So we have sigma from n equals 0 to infinity, n factorial over n plus 1 factorial plus n plus 2 factorial. So we use the same stuff here, that n plus 2 factorial is n plus 2 times n plus 1 factorial. So we have n plus 1 factorial as the common factor. So we have n plus 1 factorial times 1 plus n plus 2. So we have n plus 1 factorial times n plus 3. And here, n plus 1 factorial equals n plus 1 times n factorial. So if we divide the numerator and denominator with n factorial, we have n plus 1 left here. So we have the sum of 1 over n plus 1 n plus 3. So we have this series. Here, let us express this series as the limit of the partial sum. So we have limit n approaches infinity of sigma 1 over k plus 1, k plus 3 from k equals 0 to n. And this type of partial sum is very famous. We change this term into the difference between two terms, 1 over k plus 1 minus 1 over k plus 3. Then we require 1/2 here. This is one of the most famous methods of partial fraction. If you want to split 1 over ab into the difference 1 over a minus 1 over b, then this difference must be multiplied with 1 over b minus a. So if we write this partial sum in an expanded form, we have 1/2 at the front. And first we have 1 over 1 minus 1 over 3. Then we have 1 over 2 minus 1 over 4. Then 1 over 3 minus 1 over 5. Then 1 over 4 minus 1 over 6. And so on. And the last two terms are, when k equals n minus 1, we have 1 over n minus 1 over n plus 2. And when k equals n, we have 1 over n plus 1 minus 1 over n plus 3. So you can see that 1 over 3 cancel out, and 1 over 4 cancel out. And you can easily understand that 1 over 5 and 1 over 6 cancel out, and so on. And in the end of the partial sum, 1 over n and 1 over n plus 1 cancel out. So we have limit 1/2 times 1 over 1 plus 1 over 2 minus 1 over n plus 2 minus 1 over n plus 3. And if we take limit, this part goes to 0, so we have 1/2 1 over 1 plus 1 over 2, which is 3 over 4. And that is the sum of the second series. And that's all for today's video. Thank you for watching. And if you enjoyed this video, please give it a like and also subscribe to my channel. And as always, I will see you in another video.